Hello and welcome to this lesson. I'm now going to cover the basics of IP addressing, and we're going to be covering off the IP version 4 protocol. You may realize that there's another protocol called IPv6, and that's a much newer protocol. It has been around quite a while, but adoption isn't anywhere near the same as with IPv4. Now, we will be covering IPv6 in the next section, but for now, I'm covering IPv4 to give you a basic overview of what you need to know. Now, IP addressing is going to come up a lot in this course, so I'm basically not teaching you everything in one go. I'm going to teach you the basics now, and then we're going to learn more as we start implementing and using IP addressing in the cloud. Now, one of the first concepts I need you to understand is the fact that computers talk to each other using IP addresses. If you're a user, let's say in your company, and you want to connect to your company's website, an internal website, what you'll do is you'll put in the name of the website. So in that case, it's what's called a DNS name. So it might be mycompany.local, for example. Now, this is the same concept on the internet as well, where you might put in Microsoft.com, Amazon.com, wherever you're going. Now, when you do that, your computer will talk to something called a DNS server. That's a domain name system server. The DNS server is responsible for providing the IP address that corresponds to that domain name. So in this example, the DNS server has a zone file, and that zone file tells the computer that mycompany.local has an IP address of 192.168.0.1. That information then gets sent back to the computer, and the computer can then connect to the web server using that IP address. Now, the reason that we need the IP address is because that's the address on the network. Whether it's an internal network or the internet, computers have an address, that's an IP address, and all of the network devices that are on the internet or your internal network know how to send information and route information to that endpoint. They can't do it by DNS name, they can only do it by IP address. And that's why we need IP addresses. So let's have a look at the structure of an IP address. Now, an IP address is made up of 4 parts, and those parts are separated by dots, and they include a network and host ID. So in this case, I've color-coded it so that the blue boxes are the network ID, and the orange box is the host ID. So that means that the network ID is going to be the same for every computer on a specific network segment, whereas the host ID will be unique to every individual computer. Now, the way that we understand which portions are the network and which are the host is through something called a subnet mask. So in this case, the subnet mask says that everything with 255 is the network ID, and where we have a 0, that is where we have our host ID. Now, a bit later in the course, we're going to go into a bit more detail about how we work these out so we have the right number of hosts in our networks. Each part of an IP address or a subnet mask is made of 8 binary bits, and that's called an octet. So that means there's 8 ones or zeros or a combination of ones and zeros. Now, if we were looking at those ones and zeros only, how would we work out what the actual number should be? Well, we can use this table here. So what we have on the left-hand side is the binary value of the bit that is located here. So we have 8 bits, and the bit on the left here is known as the most significant bit, and it has a value of 128. On the right, we have the least significant bit, and that has a value of 1. So if our binary octet was all ones, then we'd have 255. And if it was all zeros, we'd have 0. So let's have a look. So if it's all zeros, then the value is obviously 0. If it's all ones, the value is 255, because that is the value of adding all these up. If you add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you'll get 255. Now, if you add up 128 plus 64, which are these 2 ones on the left here, you'll get 192. So that's how I know that this number here is 192. And again, here you've got 168. And the way you'd represent that is by having 128 plus 32 plus 8. And the 1 for the host ID here would be all zeros and then just a 1 on the far right hand side here. So hopefully that helps you to understand how to turn the binary bits into the decimal notation. Now, another way that we can represent our network and our subnet mask is in this fashion. This is known as CIDR notation, CIDR, and that stands for classless interdomain routing, which we'll be covering a bit later on in the course. But you'll see networks represented in this way. And what this means is we've got the network number, so that is the network ID portion, 192.168.0, and then we have a /24. Now the 24 represents the bits in the subnet mask. So remember, there's 8 bits in each of these, and these are all ones because it's 255. So that means 8 plus 8 plus 8 is 24, and that's why we have a /24 after the network ID. So that's a way that you'll see networks represented quite often. Now we also have several classes of IP address, and the most commonly used are Class A, Class B, and Class C. And then we often subdivide these to get different networks within them, which is again a subject which is for a bit later on. But what you can see here is with Class A, the 8 bits at the beginning are the network ID, and then the other 24 bits are all available for hosts. With Class B, the first 16 bits are for the network, the final 16 bits are for the host, and then with Class C, the first 24 bits are for the network, and then the last 8 bits are used for the host. So from that, we can see what would be the first and last addresses, and what are the total number of addresses possible for that particular network. So for the one on the bottom here, we've got the first address is going to be 1, the last address is going to be 255, and of course the first 3 parts of the network ID cannot change. So a maximum is 255 addresses. Now with a Class B, our first address is 172.16.0.1, and then we go to 172.16.255.255. That gives us 65,534 potential addresses within that particular range. So that's a lot of addresses. But now what about Class A? Here we have 10.0.0.1 to 10.255.255.255, so we have a much larger pool of potential addresses in that range. Now this is quite complicated stuff, I know, and what we're going to do later on is we're going to see how we can come up with the correct range of addresses to use when we're creating our own networks on the AWS cloud. Now there are some addresses that are reserved for private use. Now private use basically means that you can use them within your internal networks, but they're not routable on the public internet. So these addresses are defined in a request for comment, an RFC known as 1918. The address ranges are in this table here. So they're the address ranges we've already been looking at. What this means is if you use these addresses inside your internal network, that's great, but you can't use them on the internet. You cannot route these addresses on the public internet. So they're reserved purely for the addresses you give to your computers within your company networks, within your cloud. And as I mentioned before, these are not routable on the internet, so you can only use them for internal use. So I hope that all made sense, and as I mentioned, we're going to be covering IP addressing in several other lessons throughout the course, so eventually it's all going to start making a lot of sense.